Imagine an immense concert performed by an endless array of stars, planets, and moons all playing in harmony, yet there's one particular section of this cosmic symphony that has perplexed space scientists for quite some time. Exoplanets. Exoplanets are regular planets located outside our solar system, hidden far away in the Milky Way. You may be astonished to learn that among the vast number of celestial bodies, some exoplanets bear an uncanny resemblance to Earth, so tantalizingly similar in fact that they could be our planet's celestial twin. Let's dive into the intriguing realm of Proxima B. Located just 4.2 light-years away, the James Webb Space Telescope is aiding our exploration, pushing us closer to understanding these cosmic puzzles. Imagine for a moment your mind soaring across the vast astronomical expanse of our galaxy, the Milky Way, which is home to over a quadrillion exoplanets. That's number with 15 zeros. To put it into perspective, if each of these exoplanets were the size of a grain of sand, we wouldn't just fill the Grand Canyon, we'd have enough to create a second one, stretching over unimaginable distances. Remarkably, approximately 20% of these planetary bodies have been categorized as Earth-like in terms of terrain and atmospheric composition. This means that there's a 1 in 5 chance of finding a planet resembling our own, and the story doesn't end there. Surrounding these planets could be another quadrillion moons, rocky satellites like our moon dancing in gravitational lock with their parent planets. If we were to embark on the task of searching for another celestial body harboring life, or one that could potentially do so, the universe would offer a vast sea of opportunities. Now that we've covered the sheer scale of this endeavor, let's introduce the expert craftsman poised to uncover its intricate details, the James Webb Space Telescope. This cosmic detective, with its powerful central lens and advanced focal points, surpasses even the most sophisticated optical instruments. We're talking about a lens 6.5 m across, nearly 3 times the size of Hubble's. Just imagine the clarity it can achieve, revealing even the smallest flicker of a star billions of light-years away and analyzing the planets that revolve around it. What makes the James Webb Space Telescope revolutionary is not just its observational capabilities, but also its high-tech sensors and spectrographs. These instruments do much more than just observe. They can analyze and process the light reflected from distant objects, unraveling their atmospheric conditions, composition, density, and even mass. Acting as a cosmic scientist, they can determine if a planet harbors water, organic molecules, or even oxygen. The James Webb Space Telescope has the power to answer these questions, transforming it from a mere observer to a scientific genius. It's not just an improvement on its predecessor, Hubble, it's a leap forward, a quantum leap. If Hubble's revelations left you astonished, brace yourself for a true cosmic event as we extend our gaze further into the vast, complex landscape of the universe. It's worth focusing on one particular star in this celestial symphony, Proxima B. Since its discovery in 2016, this mysterious planet has intrigued astronomers and astrobiologists alike, becoming the subject of numerous hypotheses and questions. Why does it draw so much attention? Proxima B lies relatively close to Earth, only 4.2 light-years away. To put that into perspective, if we could somehow surpass the speed of light, we'd reach Proxima B in just over 4 years, about the same amount of time it takes for your favorite TV show to air its next season. But why is this proximity so important? We're talking about a universe that spans over 93.3 billion light-years from one end to the other. Finding a planet so close and so promising for scientific exploration is like finding a diamond in a mountain the size of Mount Everest. It's a gem that may hold the key to understanding life itself in the grand cosmic tapestry. What excites astronomers is not just Proxima B's closeness but the tantalizing signs that it may not only be Earth-like but potentially an Earth 2.0. Proxima B orbits within its star's habitable zone, where conditions are not too hot nor too cold but just right for liquid water to exist. Picture flowing waterfalls, winding rivers, vast lakes, and maybe even oceans as deep and mysterious as the Mariana Trench. Yet before we begin imagining ourselves visiting Proxima B, we must consider some of its key characteristics. A single day on this intriguing exoplanet lasts a staggering 11 Earth days. Imagine sunrises that not only mark the beginning of a new day but unfold slowly, resisting the urge to rush into afternoon, followed by sunsets that linger, casting prolonged golden hours that photographers dream of. While this may sound idyllic, it also presents significant challenges for its climate and potential habitability. How would human biological rhythms adapt to the light and dark cycles on Proxima B? Would we need to eat more frequently on this planet, perhaps 3 or 4 times a day? Would our sleep patterns change? The basic patterns of life as we understand them would be both strikingly similar and strangely unfamiliar. The question then becomes, how can we gather precise, reliable information about a world we've never visited? The James Webb Space Telescope comes equipped with all the tools necessary to do so, acting like a giant Swiss Army knife. It's more than just a telescope, it's an advanced research lab in space. Thanks to its state-of-the-art technology, astronomers don't just observe planets, they analyze them with a range of scientific instruments that would make a forensic lab look simple. Using advanced spectrographs, the telescope can examine the light reflected from distant exoplanets. Each element or compound in a planet's atmosphere absorbs or emits light at distinct frequencies, allowing researchers to perform a distant biopsy of these celestial bodies. They can determine not only atmospheric pressure and composition but also the potential presence of life-supporting elements like water, organic carbon, and oxygen. Space science isn't just about studying stars and planets, it's about solving cosmic mysteries. The James Webb Space Telescope isn't simply observing, it's conducting a scientific investigation, turning theories about alien worlds into testable hypotheses, confirming or disproving them, and enhancing our understanding of what might exist beyond our blue dot. And just when you thought the search had uncovered all its surprises, the story takes an unexpected turn in a twist worthy of any science fiction thriller. Researchers using the James Webb Space Telescope detected something unexpected from Proxima B, a signal so strange and intricately patterned that it hinted at the presence of an advanced civilization. The scientific community and social media were abuzz with excitement over this potential signature. Was this the moment that would forever alter our understanding of the universe and our place in it? Could this be the first definitive sign that we are not alone? The signal was unlike anything we had seen before, but just as quickly as it appeared, it vanished, leaving behind only a deep silence and a maze of questions. Was it merely a passing celestial oddity, a freak occurrence in the cosmos, or could it be something more, a deliberate message or a signal from an extraterrestrial intelligence? The mystery surrounding this signal has ignited intense debate and speculation, raising the possibility that we're not just searching for alien life but potentially even alien civilizations. But the tale doesn't end there. In an exciting shift, Harvard scientists are now taking the lead in the search for extraterrestrial intelligence, pushing the boundaries of our exploration further. They are turning the James Webb Space Telescope into an enormous Night vision tool scanning distant worlds for artificial light sources. Imagine the possibility of detecting glowing light, signs of cities or advanced technology. On distant planets, what if we could detect the faint glimmer of artificial lights on alien worlds, evidence of an advanced civilization thriving on a planet far from our own? As we continue to explore the vast expanse of space, the search for extraterrestrial life is becoming ever more exciting and promising. With advancements in technology and our growing understanding of the universe, we are closer than ever to answering the profound question, are we alone? The discovery of life beyond Earth, whether microbial or intelligent, would forever alter our understanding of the cosmos. It would raise new questions about the responsibilities of exploring these distant worlds and the possible implications of making contact with extraterrestrial civilizations. The future of space exploration is filled with immense potential for discovery and revelation. We are at the dawn of a new era, one in which we may one day look across the stars and find that we are not alone. As we venture deeper into the cosmos, we are not just discovering new planets but also redefining the concept of habitability. The more we explore, the more we question what it truly means for a planet to support life. Does life need Earth-like conditions to thrive, or could it exist under conditions we've never imagined? Could life be found on planets with harsh climates, extreme temperatures, intense radiation, or oceans filled with toxic chemical? Or could extraterrestrial life take forms entirely different from our own, using biochemical processes that are beyond our current understanding? The discovery of extremophiles on Earth, organisms that can survive in the most extreme environments, has expanded our thinking about the potential for life elsewhere, from microbes living in the deep ocean vents to bacteria thriving in boiling hot springs. Life on Earth has demonstrated remarkable adaptability. These creatures show us that life is not as fragile as we once thought. Could such life forms, or something similar, exist on planets where we once believed life was impossible? The potential for life beyond Earth now seems more feasible than ever. Advances in artificial intelligence and machine learning are also playing a crucial role in our quest for extraterrestrial life. These technologies are helping astronomers sift through enormous amounts of data, searching for patterns and anomalies that would be impossible for humans to detect on their own. AI tools enable us to analyze complex light patterns from distant exoplanets with unprecedented precision, making it easier to identify planets that may support life. This leap forward in technology is bringing us closer to answering the ultimate question, are we alone in the universe? Meanwhile, the hunt for technosignatures, the faint traces of alien technology, has sparked a new wave of excitement in the scientific community. If we could detect signs of advanced civilizations on distant worlds, it would change everything. Could the patterns we observe in the light from far-off planets be the result of intelligent life, or could they be deliberate signals sent toward us? The recent discovery of an unexplained signal from Proxima B reminded us that the universe is still full of surprises. This strange signal could be a glimpse into a much larger story, one we have only just begun to uncover. As the James Webb Space Telescope continues to collect data, it may uncover the faintest hint of extraterrestrial intelligence, whether through the detection of artificial light's unusual atmospheric compositions or electromagnetic emissions. If such a discovery were made, it would be one of the most profound moments in human history, forcing us to rethink everything we know about life, the universe, and our place in it. This exploration of space and the search for alien life go hand In and with our growing curiosity about ourselves as we look outward, we must also reflect inward. What does it mean for humanity to discover that we are not alone in the universe? How would such a discovery shape our society, our values, and our understanding of life? The potential for contact with extraterrestrial civilizations opens up a host of ethical questions. Should we actively seek to communicate with them? If we do make contact, what responsibilities do we have toward these otherworldly beings as we embark on this grand voyage of discovery? We must navigate the delicate balance between exploration and responsibility. The future of space exploration is not just about finding new planets or even discovering new forms of life. It is about expanding the boundaries of human knowledge and understanding. With each new discovery, we are rewriting our story. In the cosmos, the mysteries of the universe, once far beyond our reach, are becoming more and more accessible as we continue to push the limits of space exploration. We are on the brink of uncovering revelations that could forever alter the way we view our place in the universe. The question of whether we are alone is no longer a matter of if, but when we will find the answer. The tools at our disposal, the James Webb Space Telescope, advanced AI, and cutting-edge technologies are giving us a clearer, more detailed picture of the universe than ever before. As we peer deeper into the cosmos, we may soon discover that the universe is far more populated than we ever imagined, and when that moment comes, we will be ready to face the most exciting chapter in the history of humanity's quest for knowledge, the mysteries of Proxima B, the potential for discovering alien civilizations, and the ever-expanding search for habitable exoplanets are just the beginning. Our exploration is not just a scientific endeavor, it is a profound journey that touches on the deepest questions of existence, purpose, and the very nature of life itself. The future is filled with limitless possibilities, and as we continue to look toward the stars, we remain filled with wonder, anticipation, and the knowledge that the universe is waiting to reveal its secrets to us.